Thank you, Slobodan. Yes, I'm a PhD in physics, and the rest of the thing is my hobby. Philosophy is my hobby. So, which I do also yes, in parallel with my other, my primary life in physics. My talk today is about the value of epistemic democracy in the big science. The big labs, you know, the big science, large facilities, big funding, long duration of experiments. So, and my talk is about this physics experiment and experiments and their organization. So, basically, the structure of my talk is the following. First, I will discuss the social structure of high-energy physics based on and referring to a few the most prominent accounts, and will shortly argue with them some of their statements. And then I will discuss the social structure of big science and introduce, or better to say, discuss also the notion of epistemic democracy in its expansive understanding, and explain how I'm going to apply it to understanding the processes in the social structure of a big science. And then discuss my own simulation model. It is sort of an original but simple model. So far, I am still working on developing it. It is not borrowed from like economy and sort of original, but so far it's simple epistemic model, and discuss the results and my conclusions. Give you my conclusions in the end. So basically. As for the social structure and social organization of the big science, as you know, there are few very well-known accounts of this structure. Both of them dated in the middle of 80s of the last century. First of them belongs to Peter Gallison, and it described in his book, a prominent book, How Experiments End. First of all, he noticed, studying the structure of the collaborations in the big science, he noticed the division of labor between the groups such as theorists, experimentalists, and instrumentalists. And also, he proposed the explanation of the processes there, referring to languages. In his view, they speak different languages, such as pidgins and creoles, create interlanguages for their communications. And he compared these groups with the tribes, sort of interaction between tribes or interaction between tribes and colonists. And in his view, the dominating language group, like theorists, they, in certain aspect, they prevent the spread of their language to the less epistemically advantaged group. And the questionable thing here is the language. I will get to this a bit later. The other very important account of the big science structure is the one described by Sharon Trevick in her book Beam Times and Lifetimes. She also noticed the division between theorists and experimentalists, and also based on this division hierarchy in science, is hierarchy of sciences, physics on the top and humanities on the bottom, and in view of physicists, of course, because she studied high energy physics groups. And also she made several very important observations. For example, she noticed the limited verbal communication between these two groups, and the limited mobility between the two groups, and rituals of avoidance between these two groups. That's a very interesting observation. However, what is not pretty much clear in her account is that she agrees that both groups are able to come to a consensus about physics results. As for the discussion of these accounts, I think that I disagree with Peter Garrison in that aspect that those two languages that are spoken by theorists and experimentalists are not the different languages, because his example is a book on quantum field theory, has two versions. One of the most prominent books has two versions, one for experimentalists and the second for theorists. And theorists are able to read both books, while experimentalists only first one. That is not suggestive about two different languages. I think it cannot be compared to different tribes, because theorists are able to read both books. And in my view, it's better to compare these two different levels of proficiency in the same language, or native speaker and second language speaker, or a child or an adult speaker of the same language. So different vocabulary, a different restricted structure and so on, grammar, but not different languages. This language is the same. That's one of the bases of my future simulations, why this enables the simulation. And second thing, this division between the two groups cannot be compared to a division between economic groups, because that's why Marxism wouldn't work here, because it is not true that theorists are rich and experimentalists are poor and so on. No, they are on the same economic class. So that's not economic division. That's epistemic hierarchy, which leads to hierarchy in statuses and in prestige. So in Max Weber terms. So to explain this, I can propose the following table to try to understand this epistemic hierarchy in high energy physics. On the top, this is the theory and theories of phenomena, high-level theory. Second level are experimentalists. They can be of different sorts. For example, there's accelerator instrumentalists, detector instrumentalists, measurers, and data analysts. But what makes them all experimentalists is that all of them are guided by theory of phenomena. Whatever you do with accelerator, with detector, or with measuring data, you should be led and guided by the theory of phenomena. That's why it is the second level. And the difference described by Peter Garrison between instrumentalists, pure instrumentalists, and experimentalists is that experimentalists are people who are eventually have access to data analysis. That's their work has two roles. One of them preparing of instruments, of detectors, of apparatuses, and second is measuring and analyzing the data. Those people who don't have access to data analysis, they are considered pure instrumentalists, and the others are experimentalists. But the difference is only the property relationship to data. That's why the question of data distribution and open data is very, very important to implement a sort of epistemic democracy, which I will be discussing. The lowest level, the third level, is the level of not communities but boundary objects, just to understand the second level. Accelerators, people produce accelerated particles and exchange them with the second group, detector people. Detector instrumentalists get the accelerated beams and produce detector signals. Measurers get signals, produce data, and data analysts get data and produce interpretations. So that's the structure of the community. So just to underline what I am talking about, I am arguing that those groups are different, but they are not different tribes and different cultures, but the same culture, different strata in the same culture, within the same culture. This is the professional group, and division can be well described by an American sociologist Peter M. Sorokin, who proposed a division of every professional, subdivision of each professional group in 3 levels. One of them, entrepreneurs. In my view, this is theorists. They organize and control the entire business. Higher service, it is experimentalists, and wage workers. These are people who don't get access to data. So this is a better model of this community. And so now I'm getting to the definition of the epistemic democracy. And why is it possible? Because if we are speaking about culture, it's more difficult, different cultures or different tribes, it's more difficult to speak about epistemic democracy. But while we are speaking of the same community and the same culture, just different strata, it makes more sense to speak about epistemic democracy. So the notion of epistemic democracy was brought forward by feminist philosophers like Miranda Fricker and several other people in different contexts. They described a source of racial inequality in courts or different sorts of inequality with respect of the people who are not considered equal knowers based on different their qualities, for example, race or gender. And, but despite that the context is completely different from high energy physics, but the notion, the definition of the epistemic injustice, which those authors discussed, is pretty much close to what I'm talking about. For example, they define epistemic injustice literally as that someone is wronged specifically in their capacity as a knower. And they argue that the epistemic segregation isn't just, but that's ethical approach to this to this problem. They discuss two types of epistemic injustice: hermeneutical and testimonial. But not getting into details, shortly the bottom line is both of them are defined as, for example, exclusion of certain groups from certain discourses. And we see from the model on the previous page that the accelerator people and the pure instrumentalists who don't get access to data are very frequently excluded from the data analysis discourses. And the people who are performing the data analysis are very often excluded from the theoretical, high-level theoretical discourses. This creates inequality very similar to that described by Fricker, but in a sort of expensive understanding. So, now I'm getting to my simulation model. So, in this simulation model, I'm posing the research question: how does the number of experimentalists in the group, in the collaboration in big science, doing theory affects the probability of empirically adequate claims? I define the sort of epistemic democracy in a big science as the situation where both groups, theorists and experimentalists, can freely do both sorts of activities. Theorists can do experiments and experimentalists can do theory. And in my model, I have only theorists and experimentalists, no instrumentalists, because as I have argued that instrumentalists is just the same the same experimentalist, but just whose access to the data analysis is restricted. And there's the question of access to the data. That's not the question of epistemic question. And sort of in my model, I assume for each theory, not more than 100 theorists exist and active in the field. That's an assumption, for example. If you are thinking of a Higgs boson, not more than 100 theoretical models can exist. That's just a limitation. And I'm assuming the probability for a theorist to make a right claim, a right empirically adequate claim, a theoretical claim of 60%. This is the number borrowed from one of the Kevin's papers. I don't know where this number is coming from, but it sounds reasonable. So I'm assuming 60%. What it means in my model, if I have 100 theories, I randomly sample them and assign weights. In 60% cases, I assign them a weight of unity, so this is a right claim, or 0. In 40%, 0 is a wrong claim. So the initial weights are randomly sampled. Then experimentalists in the group can belong to one of the 3 different types. One of them I call credulists. And those people, experimentalists who just making the data analysis or preparing their empirical claim, they simply ask n theories, each of which has either weight of unity or 0, and takes the average of these claims. And average claims are aggregated then. And then the second sort of experimentalists is subjective reductionists. Those people who know some basic knowledge of theory, but not sufficient to be theorists themselves. Just theoretically literate people. There is a lot of such people usually in the collaborations. They can not only ask theories, but they can ascribe to each of the claims a weight based on their own subjective understanding, their own background knowledge, and their own judgments about this theory. How I sample this? I'm sampling that such subjective reductionist asks a theorist, and if the theorist has a probability 1, he is right. In this case, such subjective reductionist ascribes it a weight of 0.6. So 60% probability that he can determine that this theorist is right. So it is 0.6. But if the theorist has 0, it ascribes the complementary number 0.4 to make up unity. The scores also are averaged and aggregated. And the third sort of experimentalists is objective reductionists, people who are as qualified in theory as theorists, and also they don't need to ask other theorists. They can make own theoretical statements, and in this case they are sampled in the same way as theorists. They are ascribed weight either 0 or 1. In 60% it is 1. And finally, the total number of experimentalists is composed of the sum of all these 3 types of experimentalists. So, and the input in experiments in my simulation, I am entering and assuming a certain number of experimentalists in the collaboration. In a mega experiment, I'm assuming 300 people. It's like a big experiment at CERN. Or for the small experiment, I'm assuming the number of 100 people in the collaboration. That's a bit a big number, but I cannot get below 100 because the model is statistical, and if I get to less than 100, the statistical fluctuations become high. So, what I do, I'm assuming in my input, I assume the number of objective reductionists, just make an assumption, and based on this, I vary the number of credulists and calculate the number of subjective reductionists. And then I calculate the scores separately for each of them. And the score is calculated by this equation. That is a sum of scores for credulists plus sum of score of objective reductionists plus a sum of scores for subjective reductionists. That's in this case, this score is not a probability. It is sort of objective function or optimization function. And so my outputs look like this, so that's just a part of output. I enter the number of experimentalists, 3,000. Then I'm assuming that 2,000 of them are objective reductionists. How many theories they are asking? 50. And then I calculate for 3,000 of experimentalists total, I have 2,000 objective reductionists, and the rest 1,000 is 10 subjective and 990, 10 credulist and 990 subjective. Then this number runs from 10 to 1,000, and the subjective decreases in the same proportion. And the last column is the score. This, for fun, is called truth. So, the results of the simulations. The results, for example, this is the simulations for 3,000 of experimentalists. The horizontal axis, this is the number of credulists, and vertical axis, the aggregate score. The horizontal top axis is the number of subjective reductionists. If the bottom axis increases, the top one decreases. First, let's look at the blue line. That's the line for 100 objective reductionists only in the experiment. And we see that with the increase of number of credulists, the score slightly grows. So basically, that's suggestive of the following, that credulist, it is better in such experiment, given a fixed number of objective reductionists, it is better for such experiment if you are not as qualified as theorist in theory. So if you are not objective reductionist, it is better to be a credulist. It is better to just ask theorists and not to try to make own judgments about their work. So if you are credulist in such experiment, just listen to theorists and do not doubt in what they are saying. However, if we compare the blue line with the green line, which is the line for 2,000 of objective reductionists, so we see that it is much significantly higher. So it is given the same number of experimentalists, it is better. The more objective reductionists, the better. Objective reductionists, I am calling the people, to remind you, who are as qualified as theorists in theory. So experimentalist theorists, but in terms of epistemic democracy, that's the most epistemic democratic people who do both sorts of activities. So, and this quantity grows with the number of such people who do both theory and experiments. And second, what is interesting observation here, which I can't yet explain, I am working on this, is that given the same number of experimentalists, 3,000, and the same number of objective reductionists, if you vary the number of theorists whom credulists ask, it looks like for certain number, for 600 credulists, it is better to ask just 10 theorists than 100. So there is some minimum at which the less theorists you ask, the better. That's not yet explainable effect. I am working on this. I am not just making this claim, just an observation. For the small experiment, which has only 100 of experimentalists, we see that, for example, if we vary the number of objective reductionists, 80 is 80%, is blue line, and the red is 10 objective reductionists. You see this effect is much smaller than for a big experiment, but it's still notable thing that it is better to do both theory and experiments than just experiment and ask theorists. However, if you look at the number of credulists, we see that for such a small experiment, this growth of this line is not significant. This means that basically for such small experiment, if you are not theorist in experiment, it doesn't matter whether you are credulist or subjective reductionist. Do whatever you want, and if you don't know theory well, just the other things do not matter. So, and for the last plot about the simulations, I'm plotting here on the same graph the curve for small experiment, 100 people, and big experiment, 3,000 people. And I am assuming 10% are objective reductionists. 10% means different, because for 100 experimentalists, 10% is 10 people, but for 3,000 it's 300 people. But in percentile, it is the same. So for 10% of objective reductionists, we see that if we increase the percent of the rest of credulists, the behaviors of the curve is the same. This would mean that for both big experiment and small experiment, the score normalized per one person is the same and does not depend on the size of the experiment. However, that's a little bit contradict to the observation, for example, by Slobodan and his colleagues, that small experiments are more efficient than the big ones. But I can explain this in the following way. In my model, I don't model any social interactions. This is just sort of epistemic function, epistemic optimization function. But this difference between big and small experiment can come from solely from the social dimension. Or the other possible explanation, the publication efficiency of experiments is not related to the epistemic score in this model. That's another possibility. And so my conclusions, I'm coming to my conclusions. First of all, I'm arguing that theorists, experimentalists, and also such sort of them as instrumentalists are more social and epistemic strata than cultures and languages. Both sorts of experimentalists are guided by phenomenal theory. That's why they are all experimentalists. And the difference between them is only in their ability to get access to experimental data. The stratification between them has some ethical implications, as can be understood through the expansive understanding of the feminist epistemology. And in this model, in my simulation model, I studied the epistemic democracy, which I assumed as the ability of both theorists and experimentalists do each other's source of activity. And I simulated for big experiment composed of 3,000 of people and small of 100 of people. And I'm coming to the following observation. Given certain number of objective reductionists, credulists perform better than subjective reductionists. So do not question theory if you are not as qualified as theorists in theory. That's one statement. Second, the more objective reductionists in the experimentation, the better. So experimentalists should do theory and should become qualified in theory and do theory to make such experiments more efficient. And the third observation is that for small experiments, only number of such objective reductionists matter. For them, it does not matter whether you are credulist or subjective reductionist. But in all three cases, to do both experimentation and theory is better than do only one source of activity. That's my conclusion. So epistemic democracy is not only ethically beneficial, but also epistemically beneficial. Thank you for your attention.